Okay. So this is good bell work. I think we've done questions like this in grade 9. I know I teach these types of questions in my grade 9 applied class. It's going to be more complex. So we're starting off with a very, very basic, no algebraic terms, and then we're going to turn it into, it's going to get more complex. Let's start off with the first one. What strategy did you use to determine the area for the shaded piece here for that first one? Austin? Okay, so I'm going to find the area of the hole. And what's the formula for area of a rectangle again? So when I do length times width here, I have 12 times 15. What did that give me, Austin? Pardon? Thank you. What is this? Centimeters squared. And then we calculate the area of the smaller rectangle. Now, maybe you would want to write this larger. You kind of want to define so that the reader knows that you know. Then I would go to the area of the smaller one. So I'm going to put area, put a little s there. Again, that's 8 times 6. That gives us 48 centimeters squared. Now, Austin, why am I subtracting? Okay, so the whole area would be the 180. This 48 is what? Okay. So for me to figure out the total, what do I do? 180 minus 48, and what did I get? 132 centimeters squared. How many of you got 132 centimeters squared? Okay, good. How about this one? This one's a little bit tricky. What strategy did you use to calculate this shape here? Zach? So we did this one. So you broke it up. So I'm going to call this shape, I'll do numbers. So this is number 1. This is number 2. How many of you broke up the shape in this way? Okay. Doesn't matter which way you break it up, you should still get the same. So if I'm calculating the area of shape 1, what did I do? Good. And then what did you do? Okay, but I don't see a 3 on there. So Zach is saying this is 3. How many of you calculated that side to be 3? It makes absolute sense. The distance from here to here is 10. I know the distance from here to here is 7. This distance is smaller than this, not as large as smaller than that. So I subtract those two highlighted pieces from each other and I get 3. So 3 times 2, which gives me 6. And then what did you do with your final answer? Area equals 42 plus 6. How many of you were able to get 48 centimeters squared? Okay, that one was a little bit trickier. You can erase your desk. We're going to get on with today's note. You're welcome. Okay, so what we are doing today is we are applying what we know. So we've talked about collecting like terms. We've talked about multiplying binomials, trinomials, monomials together. We're putting it all together with some applications for some formulas. So it says here, for the rectangular prism, write an expression that represents the volume and the surface area. So I cut this out. This was the grade 9 academic EQAO sheet.
But at this time, we'd like to call down all grade 11 classes to the small gym.
Well, that's fun.
All staff and students in grade 11 classes at this time.
Okay, so this was the formula sheet that was given. We're going to practice writing expressions. These are good application questions that you can expect to see on either a quiz or a test. So when it asks for the volume, what is the formula for volume of a rectangular prism? It's up there. What is it? Volume of a rectangular prism. Thank you, Nick. Volume equals length times width times height. So what do you think? If this is the rectangular prism that I'm calculating the volume of, what will I put in here? What will my next line read? Austin? Volume equals? 4y times? Good. So if we look here, my length, I've labeled this as my length. This is my width. This is my height. So this would be a typical, you would get 1 mark for writing this expression out. Now I have to simplify this. What do I have to do to simplify this? What do I have to do? Length times width times height. 3x times 4y times 2y. What do I have to do? What would be the first thing I would write down as part of my answer? Austin? That all says multiply. So, absolutely you can. Nathan? Good. So, okay, hang on. Okay, so we take all the coefficients. 3 times 4 times 2. Doesn't matter what the variables are. If you're multiplying, that kind of goes away. Only when you're adding and subtracting do like terms count. So we do 3 times 4 times 2, which gives me 24, and a phone ring. Hello? Hi. Nothing? Okay, so I have 24. Nathan, continue. What do I do now? X, Y. How'd you get the cubed? No. When I'm just multiplying. So there's no units included, so I don't, because there's no centimeters, millimeters, whatever. These are just variables. So I have my x because it stays there. This is y to the exponent 1, y to the exponent 2. So it becomes 24xy squared. The units are always cubed. These aren't units. X represents a variable, which could be any number. Thank you. Okay, now the next one, which is a little bit tricky, is surface area. Surface area equals, if I write my formula down, here's my formula. 2, I'm going to use square brackets, width times the height plus length times the width plus length times the height. If you were, I'm probably not going to give you the volume formula of a rectangular prism, but I will give you the formula for surface area. That's a little bit of a tricky one. So if I were to ask you to write me an expression that represents the surface area, what would you write down on the next line? What would you write down? Zach, go ahead. For what? Good. Okay, I'm going to go around the U's, see how we simplify this. And I'm going to do each bit. So I have the square brackets. I'm not going to count that. I'm going to simplify what's in the brackets. So simplifying what's in the brackets means I'm going to multiply this part here. So Laura, I'm going to start here. 2 square bracket. What do I write next? I'm multiplying these two. Thank you. Nick, go ahead. 12, just xy. No square, because there's only one x, one y. So it just stays xy plus. Good. So I have that as a simplified, right? I've simplified one part of the bracket. Nick, what do you notice about what's on the inside of the? I do. So what would I write down on my next line? What would I write on my next line? 2 bracket. Beautiful. No. Very good. That's only for multiplication when we touch the exponents. If we're just adding or subtracting, the exponents stay the same. So Nathan, what would be my final answer here? Or what do I have to do next? Good. I have to use the distributive property in. So what would be my final answer? Beautiful. That's my final answer. Does anyone have any questions? Okay. All right, so this is the same picture that we dealt with the bell work. It says, write and simplify an expression to represent the area of this figure. What do you mean? It's x minus 1. This side length x plus 6. This side length x, this side length is just 4. What do you mean? How do you know x is 1? When did I tell you x was 1? There is a 1 in front of the x. The coefficient. That's like saying 1x. There, we don't know anything for x. I don't know what x is, so I'm going to leave it as a variable. So when I simplify an expression, I'm going to have a variable in it. It will be x something. So we're going to start off with the same way that we kind of did the bell work. And I'm going to go with the way that Zach broke up the triangle. So I'm going to split this in 2. I'm going to call this is my first shape. This is my second shape. I can calculate the area of my first shape. Area equals length times width. Danielle, what would the length be? I'm going to put it, sorry, number 1 here. That's saying like the area of the first shape, and I've labeled the first shape. Yeah, 4 times x. And what does that simplify to be, Carissa? Beautiful. So this shape here, this 4x, is the area of this part here. Okay, now I have to figure out the area of the second shape. So I'm going to start here. Area of the second shape is length times width. Carissa, do I know what my length is? No. I have to figure it out. Now, similar to what we did in this very, very first example, to figure out this length, I have to do some subtraction. 10 minus 7. This one, what math do I have to do here? Nick? Yeah. This is the full length, which is x plus 6. I want just that little bit. Hello? Hi. I can't talk right now. I gotta go. Are you okay? Add files. Yep. Okay. So I have this x plus 6. I know this length here. See how they read in the same direction? That's how you'll know you're going to either add or subtract them. I'm not going to add because it's not bigger than this. So this little section here is x plus 6 minus 4. I got the x plus 6 from here. I got the 4 from here. I subtract them. What do I get, Zach, when I simplify that expression right there? Yep. So I know that this is x plus 2. This is x minus 1. So David, what will I write next? Excellent. What do I do next, Rob? Good. So what do I do? X times x equals, good. Keep going. So what do I write? Good. Good. Very good. So I'm using FOIL there. Binomial times a binomial. I can use FOIL. Sarah, I can simplify this. How do I simplify this? Yep. Not negative x. This would be saying, good. Excellent. Okay, so now I have the area of shape 1. I have the area of shape 2, Laura. How do I figure out the total area of this, Kevin? Good, so what will I write? Good. Jericho, what's my next step going to be here? I have to simplify this. Good, so what will I write? Good. Does anyone know why I started with, I had 4x up here. Why did Jericho put x squared first? Why did he put that first? No, he's not. We always want to start with the highest exponent. Okay, that's typically how you'll see the answers. So I have here x squared plus 5x minus 2 is the final answer. This question is worth a lot of marks. So you want to make sure you're going to get a chance to practice this. You want to make sure that you understand it, okay? Yeah. Well, we're going to find it a little later, so hold on. Okay, this one's a little bit different. Again, same exact picture. I have to find the area of the shaded region. So, Vanessa, what do I have to do here? Good. So I need to find the area of the shaded. I'm going to put an S for shaded. So what would I write to find the area of the shaded part? Good. Ben, help me out here. Good. Excellent. What do I get? 2. YX and XY are the same. Typically, you write it in alphabetical order. So you can write YX. It's the same as writing XY. I just always write it alphabetical, so it's the same thing. Okay, keep going. So what do I write? Plus 2OI. Good. Austin, what do you notice about this? There is? Here's an interesting case where I actually don't have like terms. And if you look at the binomials, how could I tell right away if I'm not going to have like terms? What makes this different? There's one x and then there's a constant. So I know that there's not going to be like terms if I have two binomials that don't have the same variables. Okay, so that's the area of my shaded region. What's my next step going to be, Laura? Okay, well, I have the area of this whole shape here. Oh, I shouldn't put S. I should just put A. I'm sorry. Because it's the area of the whole shape. Thank you. So I found out the area of the whole shape. From what? Good. So I need to find the area of what? The area of the white one. And so what will I write? Length times width. Which is? Nick? No, I'm... Okay, 2y. Go, Laura. Good. Nick, you're up. I gotta simplify it. I wrote the expression for the area of the weight part. Now I gotta simplify it. Minus yx or xy. Doesn't matter. Okay, so now I have my the total area. I have the area of this white part here. Nathan, what do I have to do to figure out the total shaded area? Good. Now you have to be careful here. I'm going to write the area of the total for, good, 4y squared plus 2xy plus 2y plus x. I'm going to minus it. I have to minus it from the whole thing, the whole white part. So when I'm subtracting something, I'm going to put this in brackets, or I have to put it in brackets. Okay, so be careful there. If you if you if you just forgot the brackets, you're going to get the wrong answer because actually you're not even minusing this last part here. So when you're subtracting something, you're subtracting all of it, which is why we put it in brackets. Now, what would be my next step here? I have brackets, Danielle. So what do I have to do when I have brackets? Good. So what number is out front of this bracket? Excellent. So I take this -1 and I multiply it inside the bracket. So Carissa, can you tell me what I'll write with? Or what I'll write with? What I'll write? That's perfect. Nick, you're up. What's my next step going to be? Good. So what do I write? Good. Okay, Zach, what do I get for a final answer? Okay, good. These cancel out. If 4 minus 4 is 0, I get nothing. I don't even write anything. So then I skip right to here. 2 plus 2 gives me 4xy plus 2y plus x. Holy long question. That's my final answer. "3M just hit you in the face." Hmm? No, I said 3M just hit you in the face. This course. Okay. Example 4. Here's a little bit, our very last one. It says the length of an edge of a cube is represented by the expression 3x minus 2y. Write, expand, and simplify an expression for the surface area of the cube. Nathan? Good. So it's a cube. The length and the width are the same. So how do I show that the length and the width are the same? Okay, good. So I have 3x minus 2y times 3x minus 2y because that is it's a cube. So I'm just going to, so surface area here, I know I'm going to have length times width. How many faces are, if it's a cube, I know all sides are the same, right? How many sides are in a cube? There's my formula. There are 6 sides to a cube. You can count 1, 2, 3, 4, 5, 6. They're all the same because it's a cubed. Now when I sub this in, I have here 6 bracket 3x minus 2y. 3x minus 2y, just like Nathan said, because my length and my width are the same. In yesterday's lesson, what did I tell you to do first? What did I tell you to do first? Kevin? FOIL. I multiply using FOIL. David, can you help me out and tell me what I'll write down on the next line? Beautiful. Okay, Rob, what will be my next step here? Before I do that, which is collecting like terms. So again, notice here how in the brackets I have an x term, a y term, a y term. That's when I know I can simplify. When they don't match, I know that there won't be any simplification. So, Rob, what will I write on my next line here? Pardon? Good. Sarah, what's my last step going to be here to simplify this? Good. I use a distributive property, multiply it all in. So what do I get? Excellent. Squared. Perfect. Okay, then it says here, using the simplified expression, which is this last piece right here, calculate the surface area. Here we go. This is for you, Nick. If x equals 4 and y equals 3. You complain that there's x's and y's. Now we know what it is. So where did I end up? Jericho, here's my simplified expression, 54x squared minus 72xy plus 24y squared. I need, and this is surface area, so I'll write surface area here. What do I do if I want to find out what the actual surface area is? If x is 4 and y is 3. What will I replace x with? Yeah, so what will I replace x with? What is it telling me x is equal to? Good. And what will I replace y with? Good. So, Vanessa, can you write me the next line in this? Start with, instead of writing x, what do I write? Good. Keep going. You're right. You can do it like this. I'm going to do it times 4 times 3 squared. You don't, it means the same thing. It means the same thing. Now, I'm not going to worry too much about BEDMAS here. You have a calculator. Plug that whole thing in and tell me what you get. 54 times 4 squared minus 72 times 4 times 3 plus 24 times 3 squared. Type that into your calculator, please. And if you don't have one, then really come get one. Oh, hit the reset button in the back. What do I get? Nick? Can I get someone to confirm? Nathan, what'd you get? What? 16? I don't know what the answer is. 54 times 4 squared minus 72 times 216 centimeters squared. Good job, Nathan. Okay. Again, this one we would put in the, did anyone not get 216? if you didn't, you may want to just ask me afterwards how to get it so that you don't lose a mark for a simple calculation. Again, I'm not too worried about bad math here. You have a calculator, okay? I'm more worried about that you understand kind of the basics of it. Are we okay with that?